So good morning everyone. So in this video we are going to see the brief introduction about a stack. Here I will explain what is a stack and some of the applications of stack. Finally we will discuss what are the operations we can perform with a stack. So first, what is a stack? Stack is a linear data structure which stores collections of elements. First, we will see what is a linear data structure. Usually, linear data structure follows a particular order in which the operations are performed. So, we know that data structure is nothing. First, we will see what is a data structure. So, data structure is nothing but to storing an element so that we can easily access the element and use it for further need. So, in linear data structure, data elements are arranged sequentially or linearly. So where each and every element is attached to its previous and the next element. So let's imagine we will have a train. In train there are many compartments. Each compartments are connected to the previous and the next compartment. Like that, in linear data structure, elements are connected to the previous and the next data structure. The next topic I am going to discuss is stack. Stack follows LIFO. So LIFO is nothing but a last in first out. So this means that the data which comes last will be deleted or will be moved first. For example, if you are going to submit a note, submit a record or any observation to a ma'am's cabin, then there will be piles of note. So the note which is present at the top will be corrected first by our staff. So like that, the element which will be at the top will be removed first. That is the last element. Coming into the stack will be removed first. So this is a last in first out. So in every data structure there are two common operations. One is a insertion, another one is a deletion. So we will inserting an element or we will delete an element. Another operation we perform is a search operation. So first we will see these two operations, insertion and deletion. So stack follows some order for insertion and deletion. That's okay. LIFO, that is the last element can be deleted. We cannot delete the bottom element. Here we can see an empty stack. If we are pushing an element one. So first I will say, in stack we will say insertion. Okay, in insertion we will call it as a push and deletion we will call it as a pop. So there are two operations we will perform in stack, push and pop. So first we will have an empty stack and we are inserting an element 1. Then we are inserting an element 2 and we are inserting an element 3. So if I want to delete an element 2, I can't delete the element 2 directly because stack follows LIFO data structure. So first I want to remove. So that means I want to pop out the 3 first. Then I want to remove the 2. So this is a stack. Now we will see what are some real-time examples of a stack. So these are the common examples we will face in our life. So here we can see a piles of book, right? So if I want to remove this violet book, I can't pluck like that. If I pluck like that, all the remaining book will be fall down. So I want to remove every book on top of that. Then only I can take the desired book. Like that also, here also we will see a glass jar. We can have 3 balls inserted in it. If I want to take a ball, first I will take the topmost ball, that white ball I will take that. So this is one example of stack. Another example, we can see the cardboard balls are stacking one another the another. That means if I want to remove the third balls, then I want to remove the fifth balls first, then for fourth balls, then only I can remove the third ball, sorry. So like that, there are many examples of a stacks. The common example, they will say the piles of plate, piles of book and etc. So now next we will see how the stack will be used in our computer. Okay. So the first application is storing a function local variables and function call. So this is one of the application of the stack where it will be used in a computer memory. Here I will write some pseudocode of the program. Here in my first whenever the program get executed by the CPU, there will be 4 types of memory allocated by the computer. One is called code, another one is called data, another one is stack, and last one is called heap. So the stack, stack is a memory where the function name and the local variables and the values of the local variable will be stored. Here we will see first the compiler will execute the main memory. So the main memory it will call the in main memory it will call the sum function. So in a stack it will store the name of the function and value of the value of a and b. So a and b is a local variable to this function sum. So here it will store a equal to 2 and b equal to 3. So inside this function here I am going to call another one function called multi. So here also I will call a comma b. So here again the stack will create another one entry and fill the function name mul and another and fill the variable local will be a equal to 2 and b equal to 3. Once it print the a into b, that is 2 into 3 equals 6. Once it print the output 6, the computer memory will pop out this memory. Then it will come to this statement. Here now we will execute this statement. So it will come out and print this statement. So 2 plus 3 it will print 5. So this will be the output. So like that only our computer, like that only our program will get executed. So this is one applications of the stack. So the another application is like an undo or redo operation. So like whenever we are typing something, so for example if I write something like stack, so the each and every letter get added into a stack. So if I undo all these things, these elements get pop out from the stack. So another example is, so we will use phone, right? So when we go and see about phone history, we can see the recent call we receive will be present at the top. So these also use a stack only. Similarly, browsing history also follows the stack data set. So the pages we are visiting in internet. So if I go to Google now, here I am going to Google. So I am searching for stack and I will go to Geeks or Geeks. So now what will happen exactly is, so whenever I go to Google, the stack will be created. In the stack, first the website which we visited first will be the Google. So it will be present, and the topmost we will visit this stack data structure. Now if stack data structure website, now if I want to move backward, so the element which is present at the top will be removed and it will come back to the previous page. So this is also one example of this stack. So next we will see what was the operations present in this stack. So as I already mentioned, there are two most common operations in every data structure. One is insertion, another one is a deletion. So in stack we will call it as insertion we will call it as a push, and deletion we will call it as a pop. So we can insert an element, and we can delete an element also, and we will maintain one top pointer. So using this top pointer only we can insert or delete an element. So peek is nothing but seeing searching an index, seeing an element at a particular position. So if I have an element like 1, 2, 3, 4. So if I want to see what is the element present at the second position, then I want to use a peek operation. So another operation is a stack top. It will return the element which is present at the top. So is empty is indicating whether the stack is empty or not, and is full is indicating whether the stack is full or not. So these are the common operations perform with a stack. So how we can implement a stack? So we can implement a stack by using two data sets. One is array and another one is a linked list. This is because array and linked list are the physical data structure. So array will store the element continuously in a memory. Linked list will store not storing an element continuously, but there will be some link using a pointer. So we will see all these stuff in our next videos, how we are going to implement a stack using array and the linked list. So, and some common problems we can solve using a stack is a parenthesis matching and increase to postfix conversion. So these problems also we can see in the next video when we will see the code. And thank you. I will hope this video will help you to learn the stack and to understand the introduction about the stack. Thank you. Thank you once again.